Hello everybody, hope everybody's doing well. I'm just going to go over the problems on the multiple choice that turned out to be somewhat problematic, and there were not a lot of them. There were only about 6 problems that I can see that a lot of people had difficulty with. So this should be a relatively short video, if you're happy about that. And so let's hit this. This first one that looked bad was number 6. All right, number 6. Which one of these happens to be the correct motion for the wave? So I'm going to show you another way to think about this because people still are getting this wrong. Let's say here's my wave, okay? And I'm going to draw equilibrium position right there. And let's say here's that point on that wave. And the wave is moving in this direction. That's the direction the energy is moving. Another way to figure out which way the points are going to be moving is to draw the wave a split second later. So what I'm going to do is I'm going to put points just to the right of where it crosses rest position and just to the right of each crest and each trough. And I'm going to draw the wave as a dotted line. Go using those points as a guide. There's my wave. This can only move up and down. This point has to move up. Okay? All the points from here to here, from the trough to the crest, all these points are getting lifted up. And all these points from the crest to the trough are getting dropped down. These points here, all right, these points here are all getting dropped down. So the wave comes through, this pencils the wave, and this marker is where that point is. The wave comes through and lifts that point up as it goes through. Then after the crest comes through, the point goes down. All right, that was the first one that was bad. 7 looks like it was a little problematic. Same problem, same exact problem. Understand the trough is moving in. So a second later, this trough is going to be here. This has just moved down. Okay? Now, after the trough is passed, the crest is going to be coming through. So then it's going to start to move it back up again. So at first, this comes through, trough comes through, the point goes down, then it starts to move up as it's going towards that crest coming in. Okay? That was 7. 9. In a mechanical wave, energy is related to the amplitude, how far that object moves from rest position. If I had, this is number 9. If I had a drum, I hit the drum once, it might give you a wave like this. Hit the wave harder, hit it harder, you've got a bigger amplitude, you've got more energy in that wave. And that was 9. 14, the next one that was bad. If the frequency of a periodic wave is doubled, okay? If the frequency of a periodic wave, the period of the wave is, well, you know, period equals 1 over frequency. Okay, so let's put in some simple numbers. Let's put in 1 for the frequency. I can do 1. Now I'm going to double the frequency. Clearly, it's half of what it was before. It's going twice as fast. It's going like this, and then it's going like this. Yeah, there'd be twice as many waves per unit time, per second. That means the time for each wave is half of what it was before. That was 14. 28. Yeah, we actually had a good run in here. 28. 2 waves. having the same frequency and amplitude are in the same medium. Maximum constructive interference occurs when the phase difference. All right, when these two waves meet, I got constructive interference, and I'll write it up here. These, when they meet together, they line up with each other, right? Actually, it gives you a much bigger wave when it does that. But they line up. That's in phase. That's a 0 degree phase difference between the two of them. If they were meeting like this, and they came together, those are out of phase. These guys would be considered 180 degrees or half a wavelength off from each other. In phase is 0, gives you constructive interference. Out of phase, 180 degrees, gives you destructive interference. And last but not least, I said this is a quick one. That was 36. Parallel waves. Remember, a long wavelength and a small slit gives you best gives you best diffraction. Forgive me. These guys are going to come through just like that. You're going to have the same thing here. Yeah, there's some curving on the edges. But when you get the long wavelength and a small slit, that's when the waves propagate away and the slit looks like the source. Okay? That's pretty much it. I didn't get any emails for anything that people needed extra help with. So I'm going to do that. I'm going to finish going through your homeworks today. I hope you guys went through the sheets that I did the corrections on and did your corrections and submitted them. I'm actually really looking through them to make sure you understood everything. All right, that's it. I wish you guys a nice weekend. We have a final date. It's June 12th. It's the last day for you, and it's big time of the last day for me. So, and I'll talk to you guys. I might like to do something then, a little different. All right, see you later. Have a great day. Have a great weekend. Enjoy the nice weather. Bye-bye.